So, hello everyone. We are starting the chapter Electrolysis, class 10. So, very important chapter in view of your higher classes, means 11, 12. And remember, this is exam time, so you should put a great effort on doing this. So, without wasting time, we'll start electrolysis. Remember, electrolysis is the process by which we can dissociate, we can break a compound with the help of electricity, okay, in its constituent ions. So electrolysis basically is the decomposition or dissociation of compound into its constituent ions due to the passage of electric current. Remember, this is called electrolysis. So before going into this, we will be starting with any substance can be categorized into two substances. One is electrolyte, another is called non-electrolyte. So any substance, so remember, so any substance, you can classify any substance into two categories. One is called electrolyte, okay, and another is called non-electrolyte. Remember, non-electrolyte. And remember, electrolytes are the substance which allows electrolysis to take place, okay, which allows the electric current to flow through them. And non-electrolytes are the substances which does not allow electric current to flow through them, okay, as you have learned about conductors and insulators, okay. So before going into the chapter, let us learn about the definition of electrolysis. We'll start with electrolysis. What is it? Remember, the dissociation of a chemical compound, into its constituent ions in molten or fused state into its constituent due to the passage of electric. There are three main points. So I am writing the definition. The decomposition of a chemical compound, you should write it like this: the decomposition of a compound into its constituent ions. First kotha, in molten or fused state, then due to the passage of electric current is called, remember, electrolysis. Remember this. So let us see the key words. So the decomposition of a compound, so decomposition, main thing, or dissociation into its constituent ions, the ions which actually make that compound. This is very important, molten or fused state, not in the solid state, due to the passage of electric current. So we have got three keywords: the decomposition of a compound into its constituent ions in molten or fused state due to the passage of electric current is called electrolysis, okay. So remember, when we are talking about electrolysis, we have to know actually where and how this electrolysis takes place. Before going into this chapter, we have to know about the place where the electrolysis takes place. The place is an electrolytic cell. So remember, so we are trying to draw a rough diagram of an electrolytic cell. Let's see. Electrolytic cell. Try to copy with me. Remember, when you are copying with this, by pausing the video you should copy it, because you can see 60% of the learning will be over when you are just copying this. Okay, I'll repeat it again and again. So electrolysis lytic cell, you all know it looks like this. It is a container containing some substance which is there in the molten state. The substance in which the electrolysis takes place are called electrolyte. Remember, electrolyte. The substance where the electrolysis takes place are called electrolytes. Okay. So here we will be inserting two electrodes or the terminals from where electricity can enter into it and go out. One will be the positive electrode, another will be the negative electrode. Okay. So in positive electrode, the positive electrode is known as anode. Remember, it is known as anode, and the negative electrode from where it is doing is cathode. Okay, it is cathode. One is anode, you all know it is cathode. And remember, when electrolytic dissociation takes place, any compound, I can write AB, in aqueous state or molten state, dissociate into when electricity is passed. See, I am giving here the reversible sign. So when electricity is passed through, it is dissociated into A plus B minus. This A plus positive ions are called cations. Remember, these are cations. And this negative ion which is formed are called anions. These are called anions. Remember, always in an electrolyte, in the process of electrolysis, I am assuming here A plus resides here. This is A plus and this is B minus. So this cation, positive ion, always goes to the negative terminal due to electrostatic force of attraction. So cation always goes to the cathode and anion always goes to the anode, which is the positive terminal. So this is as simple as that. Okay. So first of all, we are introducing this chapter. So to sum up what is going on, any substance in the world can be classified into two categories. One is electrolyte, another is called a non-electrolyte. Electrolytes are the substance where the electrolysis can take place. So we can give some example of this one. Say electrolytic substance is acidified water, molten lead bromide will do. Lead bromide will do a lot of things like this. Say molten aqueous copper sulfate solution. These are all examples of electrolyte. And a non-electrolytic substance, remember, pure water. You cannot believe until you mix acid with it, it doesn't conduct electricity. So I can write pure water. Many examples are here. So remember, electrolysis, it is the decomposition, means dissociation, breaking into its constituent ions. The decomposition of a compound into its constituent ions in molten or fused state. Molten means by the application of heat when anything melts. Or fused state, same thing. Or in aqueous state. Remember, here we can write one more word, in aqueous state. Aqueous state. See here, the decomposition of a compound into its constituent ions in the molten or fused state due to passage of electric current through it. See, here I'll be adding one electrolytic cell like this. So that completes our circuit. We'll do it later. So it is called electrolysis. Electrolysis starts from or takes place in an electrolytic cell. So this is an electrolytic cell. The substance in which the electrolysis is going on is known as electrolyte. And there are two terminals, one is positive, another is negative. So positive terminal is known as anode and the negative terminal is known as cathode. And remember, I have taken an arbit compound here AB. So when we pass electric current, let us assume it is an electrolyte. So when we pass electricity through AB, AB dissociates into A plus, that is the cation, and B minus, that is I am assuming that B minus the anion. So in this electrolytic cell, we have got two types of ion. One is anion, another is cation. This is cation, this is anion. So cation always goes to the negative, positive ion goes to the negative terminal, that is the cathode. Negative ion always goes to the anode, which is the positive terminal. Now to continue, I will be starting with anions and cations. So it is very important in electrolysis, anions and cations. You all know this. So in periodic table and chemical bonding, we have learned that any substance, any elements which tries to lose electron, tries to gain electron, will form a negative ion. And negative ions always known as anions. And the elements which loses electrons in time of any chemical reaction forms positive ion. Positive ions are called cations. So in anions we can write negative ions. Negative ions are called anions. Who forms negative ions? The element for which are there in period 5, 6 and 7. Remember, this is for your conceptual knowledge or any question which comes from outside. So elements from group 5, 6 and 7 are the elements which frequently forms anions. So I am giving few examples of it. Say chlorine always loses one electron to form Cl minus. Now for what this year ICSC have given a notice or the circular like this, you have to mention the state of this ion. So we will go by preferring to the aqueous solution. So you should write this equation now like this: chlorine aqueous, when it loses electron it becomes Cl minus aqueous. This is an example of an ion. Now similarly, oxygen aqueous will lose 2 electrons to form O minus 2 aqueous. These are called anions. Remember, anions always transmitted towards the anode. Anode is positive terminal. So negative ions are always attracted towards the positive terminal. So remember this word also, anions. Anions always moves, or you can say attracted towards the positive terminal, that is anode. So this is your anion. Now coming to the cation, cations are the positively charged ions are called cations. So we can tell it as positive ions. Positive ions are called cations. So who are the elements. Which are the elements which tends to form cations? The elements from group 1, 2 and 3 in the periodic table are the element which forms the cation. So we can write elements from group. Now see, I am relating this with electrolysis. So group 1, 2, 3. See, the elements of group 1, 2, 3 are very much eager to lose sorry, I have done it wrongly. Those are all gains electrons. Okay. I'm sorry. So after gaining the electron, this becomes negatively charged. Now the elements which loses electron, sodium, say aqueous, will lose electron to form Na plus aqueous. Say magnesium aqueous will lose 2 electrons to form Mg plus 2 aqueous. Like this it goes on. So these are called cations. So the last point, see, anions always moves or attracted towards positive terminal, that is anode, and conversely we can say cations always moves or attracted towards the negative terminal, that is called cathode. So cations always attracted towards the negative terminal, that is cathode. So this is about anion and cation. Now when we are discussing electrolysis, we will be concentrating on electrolyte. So first I'll start with classification of compound. There are two types of basically compound. One is called electrolyte, another is called non-electrolyte. So compounds can be classification of compound. Classification of compounds can be done in two ways. One is called electrolyte and another is called non-electrolyte. So I can write electrolyte and another is called non-electrolyte. So what are electrolytes? The compound which undergoes electrolysis are called electrolytes, and in the molten or fused state. And non-electrolytes are the substance which does not undergo dissociation in the molten or fused state when electric current passes through it. So the compound which undergoes dissociation with the passage of electric current are called electrolytes, and the compound which does not undergo dissociation in the fused or molten state with the passage of electric current are called non-electrolyte. Now again, electrolyte can be classified into two categories. One is called strong electrolyte, another is called weak electrolyte. So further classification, electrolyte can be classified further into two categories, and one is called strong electrolyte, and another is called weak electrolyte. So we'll carry further our discussion with the strong and weak electrolyte. So we will continue our discussion related to strong and weak electrolyte. Very important thing. So see here, strong electrolyte, and this is weak electrolyte. So in strong electrolytes, many times it was there in your ICSE exam, and remember in higher classes you will be needing this very badly. So strong electrolyte means the compounds in the aqueous state or fused state. When electricity is passed through them, they dissociates into constituent ions completely. That means the dissociation is very high. Dissociation means the breaking of one molecule into its constituent ions. So here you should write with the passage of electricity, with the passage of electricity, the dissociation of the electrolyte in its constituent ions is very high. The dissociation of electrolyte into its constituent ions is very high. That means one large amount of ions will be produced. Here the same thing we write, that is, with the passage of electricity, the dissociation of electrolyte into its constituent ions is very low. So you are in class 10, so I am just changing this word. This is very low. Now remember, when I am telling you with the passage of electricity, the dissociation of electrolyte, this is called degree of dissociation. Remember, this is a new word to you, that is called degree of dissociation. And it is indicated by the letter alpha. So degree of dissociation means the number of ions or number of molecules which dissociates into its constituent ions. This thing is called degree of dissociation. So in case of strong electrolytes, we can tell that the degree of dissociation is very high, and here the degree of dissociation is very low. Again I am telling what is degree of dissociation. Degree of dissociation means breaking of molecules into its constituent ions with the passage of electricity. So here for strong electrolyte we will write another point, that is degree of dissociation is very high. So I can write degree of dissociation is very high. Degree of dissociation is very high. Here we can say degree of dissociation is very low. So here we can say degree of dissociation is very low. And now one more thing we would like to add, that is example. What are the example of a strong electrolytes? The example of strong electrolytes are all dilute mineral acids, dilute HCl, dilute H2SO4, all are dilute, remember, and sodium hydroxide, all salts, are example NaOH, NaOH, KOH, lead bromide, all salts are this type of thing shows a very high degree of ionization. That means they splits into its constituent ions when electricity passes through them. Now here, these are weak electrolytes, means they does not undergo dissociation into its constituent ions when electricity passes through it. The example I can give is pure water is a very bad, very weak electrolytes, and remember, say all molecules. Remember all molecules, say acetic acid, acetic acids, all organic acids, all organic acids are examples of weak electrolyte. So what are strong electrolytes? The electrolytes where the degree of ionization, that means the formation or the capability of forming ions is very high, are called strong electrolytes, and where the possibility or the capability of forming ions are less are called weak electrolytes. So they can give you this type of question, why HCl is a stronger acid than acetic acid. So I am writing a question here. This is from your ICSC. Why HCl is stronger acid than acetic acid. So your answer will be in a molten state or in fused state when electricity passes through them. HCl undergo very large amount of dissociation or large degree of dissociation. That means they can produce large number of hydrogen ion and chloride ion. But in case of acetic acid, being a weak electrolyte, they does not undergo such dissociation and cannot produce such number of ions. Hence, HCl is a strong acid and acetic acid is a weak acid. So the key word for the answer is HCl is strong electrolyte and acetic acid is a weak electrolyte. You should write it like this. Dilute HCl, this is the answer, is a strong electrolyte, and acetic acid is a weak electrolyte. Remember this. So this thing in class 11, 12 and higher classes you will be doing lot of numerical related to this. So strong electrolyte, weak electrolyte is very, very important in view of your ICSE exam. The next topic we will start is the difference between electrolytic dissociation and ionization. Up to now, up to class 9, you have seen that dissociation and ionization are almost same thing, that is the splitting of compounds into its constituent ions, but there are basically few differences which are very important when you are studying the chapter electrolysis. Remember, the electrolytic dissociation is a process which takes place basically, mainly in electrovalent compound. Remember, it takes place mainly in ionic compounds, in electrovalent or ionic compounds. Remember, ionic compound. And where the ionization means formation of ions takes place, it basically takes place in covalent compounds. So this ionization process, it takes place in basically mainly covalent compounds. So basically basic difference between the dissociation is electrovalent or ionic compounds. Here the ionization takes place in covalent compound. Number 2, remember in electrolytic dissociation it involves the separation of ions. That means the ions are separated. Positive ions move towards the negative terminal, negative ions moves towards the positive terminal. Or in other words, in chemistry words, I can tell it like this: anions move towards the anode and cations move towards cathode. But the ions which are moving through the electrolytes are already present in that compound. So though we know in ionic compound the ions are there which are held by very strong electrostatic force of attraction. So in electrolytic dissociation you should write it like this: here the separation of ions takes place. For the ions which are already present in the compound. So you should write it like this: here the separation of ions takes place with ions which are already present in the compound. Remember. So, and here there are no ions. So here first of all the charged ions are formed, and then those ions starts moving towards the electrode. So here, when electricity is applied, first the ions are formed, then the ion starts moving. So here with the passage of current, first ions are formed, and then the ion starts moving. Towards the respective electrodes. So moving towards the respective electrodes. So remember, what is the difference here? Ions are already present in the compound. That means ions are there. But here, remember, when we apply electricity to this electrovalent or covalent compound, first the ions are formed, and then those ions start separating towards each other. So here you can write one thing very, very importantly. Remember, for the migration of ions, so this is the key point for the migration of ions. Remember, migration of ions. Remember this, it will help you in all the classes and including your class 10. Anions always moves towards the anode and cations always move towards the cathode. Many students are there who find it very difficult to remember this. So remember, anions are negative ions. Negative ions moves towards anode. Anode, that is positive terminal. Anode is what? Positive terminal. And cations, remember, cations, those are positive ions. Positive ions moves towards cathode. Cathodes are what? Negative. So keep it in mind, these are little bit theory portion. We will gradually enter into the electrolysis of few compounds. Those will be there in your ICSE exam. But for conceptual question or 1 mark, 2 mark question in section A, you require this one. Now we are starting a very important topic that is called selective discharge of ions, or in some other books might be it is written as preferential discharge of ions. So remember, this is very important in view of your ICSE exam. Selective discharge of ions means when up to now what we have learned that in an electrolyte, if a positive ion and a negative ion is there, so the cation always goes to the cathode and the anion always goes to the anode. This is a simple thing. But if there are more than one cation or more than one anion present in an electrolyte, then what happens? So these two are the charts. These are familiar charts. This one is, you know that this is a electrochemical series, and I have written, it is given in your book. So see here, the cations are arranged like this: potassium, calcium, sodium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury and silver. So as we go down the group, listen to it very carefully and see this arrow. As we go down the group, it is written increasing ease of discharge as cathode, means more easily the ions which are present below in the activity series will be discharged, means increasing ease of reduction. Remember here one thing, that in cathode, remember, cathode, always what happens, which ions migrates, the remember, in cathodes always cations migrates. So cations when migrates there, say I am taking the example of K plus. Now first of all see how K plus is formed. Potassium after losing one electron becomes K plus. When, and this is a cation, when this cation goes to the cathode, what it actually does, this K plus will accept one electron from the cathode to form K, neutral positive ion, neutral positive element. So in the cathode there is a gain of electron, and remember, gain of electron means reduction. So here what is taking place, that is called reduction. And so I am repeating myself one more time. Cations when migrates to the cathode, they accept one electron from the cathode. When any object, any element gains electrons, it becomes what? Neutral. And here what is the reaction taking place? Reduction. So this chart you have to remember, say in a solution or an electrolyte, potassium, calcium are present. So which one will be liberated first? Calcium. Why? Calcium is placed below in the activity series. Now see here, let us assume aluminium and iron are present in a solution. So iron will be liberated first at the cathode. So the cation which are placed below in the activity series will be liberated first. And these are, for your knowledge, that is increasing or ease of discharge in the cathode, increasing ease of reduction. That means the elements which are placed below this activity series will be reduced very easily. So they can be discharged very easily to the cathode. Same thing, this is a new thing to you. This is the case for anions. So at the top, this is sulfate ion, then nitrate, then chloride, bromide, iodide and hydroxide. See the same thing, see this arrow. As we go down this series, increasing ease of discharge at cathode and anode. So if reduction takes place at cathode, so at anode, what will happen? So at anode, remember this, at anode, what will happen? So the negatively charged, I am taking this example, Cl minus, remember, Cl minus will lose one electron to produce chlorine. And when any element loses electron, it becomes oxidized. So here oxidation takes place. Here oxidation takes place. So to sum up, so in this series, if there are any electrolyte where hydroxide and iodides are present as negative elements or the anions, hydroxides will be liberated first. If sulfate and chloride are present, chloride will be liberated first as they are placed below in the activity series. So here, this is called preferential discharge. I am writing this, remember, this is called preferential discharge. Discharge of anion or cation. Remember this is called selective discharge of anions and cations. Now we will be learning. So again, this is the last time I am repeating. We will be now after this, after completing this topic, we will be going for few compounds where we will see how the discharge taking place. So here the positive ion which are placed below the activity series will be liberated first, and here for the negative ion, so you have to remember this series. So which are placed below will be liberated first at the anode. Now I will be starting the factors affecting the selective discharge. So it is also a very important topic, that is factors affecting the selective discharge. Remember, in exam they can give preferential discharge also. So number one factor, position of anion or cation in the activity series. So just now we have elaborated, we have discussed this. So number one answer, number 1 point, position of anion or cation in the activity series. So to elaborate this, you know up to now that the elements, the anions or the cations which are placed below will be liberated first. Number 2, concentration of the electrolyte. Number 2 point is concentration of the electrolyte. So of the electrolyte. So more the concentration, more will be the discharge. Less the concentration, less will be the discharge. But there is a problem. So in when 2012 or 13, they have given that dilute HCl is much more strong electrolyte than a concentrated HCl. There your system goes wrong. There you should tell that the dilute acids dissociates more than concentrated acids. So we will be discussing our question answer later. Let me cover the theory part. And number 3, remember nature of the electrode. Number 3 is nature of the electrode. So these are the few points you should keep it in mind for the preferential discharge of ions. So for preferential discharge, you have to remember this series. The ions which are present below will be liberated first, and the preferential discharge depends on the following factors. Number 1, position of the anion or cation in the activity series. Number 2, concentration of the electrolyte. And number 3, nature of the electrode. This point we will little bit elaborate in the next video. So we will elaborate little bit about nature of the electrode. Remember, this is not so important in view of your ICSC, but I am doing it for you, and you should know little bit about this one. There are, remember, electrodes means you all know this. This is electrolytic cell, and remember I have got the opportunity to teach you as I wish, because you are not in front of me, so I can do anything. So this is a one directional traffic. You cannot ask me anything, but please after completion of this, look at those videos repeatedly, and we will soon meet in Zoom apps, or if permits that we will be in front of you, then we will see and we will clear our doubts, because a large huge syllabus is given, especially in Douglas Memorial. All the schools have given a very big syllabus in the midterm, so we will try our level best to cover that syllabus. See, this is electrode. These are electrodes. The positive and the negative terminals are called electrodes. So nature of the electrode plays a very important role in electrolysis. There are various types of electrodes in practice. Remember that electrochemical cell or a battery plays a very important role in all the vehicles that are running in the road, starting from a motorcycle to a big truck or a bus. And remember, and inverters, everything. This is a huge field of study, that is electrochemical cell. That's why I will be elaborating little bit about this nature of the electrodes. Basically, electrodes can be classified into two categories. One is called inert electrodes, another is called active electrodes. So we can classify electrodes into basically two categories. One is called inert electrode, and another is called active electrodes. So remember this is called active electrodes, and we choose those electrodes according to our requirements and according to our use. Remember, inert electrode does not participate in electrochemical reactions which are taking place inside the electrochemical cell. They are inert in nature, and the examples of inert electrodes are iron, graphite, platinum, etc. So examples of inert electrodes are iron, graphite, platinum, all are inert electrodes, and they are very frequently used in electrochemical reactions or electrochemical cells. Now few active electrodes. Remember, electrolysis is used greatly in electrometallurgy, or metallurgy we will be doing that. So in purifications of metals or many applications related to electroplating, electrorefining, we will be discussing it gradually. So there we will be using the active electrodes. Here the active electrodes examples are copper, nickel, silver, etc. So we can write example as copper, silver, nickel, all are examples of active electrodes. So remember, there are one more electrode. This is I am giving you for your knowledge. It's called hydrogen electrode. that is called hydrogen electrode. What is this? No need to know about this one, just remember this name. Remember, as we have made that activity series, the electrochemical series, so in electrode also there is a series according to their activity of the electrodes. So according to the activity of the electrodes, remember, hydrogen is the scale, the electrode potential, that is called standard electrode potential. When we will be learning physics, we will be learning about the potential difference. So the potential of the hydrogen electrode is taken as 0, or it is called a standard electrode. Means all the strength of the electrodes and all the activities of the electrodes are measured with respect to this hydrogen electrode. So it is called standard electrode, and remember the activity of all the electrodes, the activity of all the electrodes, electrodes are measured with respect to hydrogen electrode. Remember, wait for 1 year, 2 year in class 12 we will be learning these elaborately. So we are continuing the preferential discharge. We know the factors affecting the preferential discharge are the concentration of the electrolyte, that is the position of the ions in the activity series, and the nature of the electrode. According to that, or with respect to that, I am a little bit giving you few knowledge about the nature of electrode. Electrode can be broadly classified as inert electrode and active electrodes. Iron, graphite, platinum are few examples of inert electrode. Copper, silver, nickel are example of active electrodes. Nobody knows in section 8. You might be having a 1 mark question from it. And hydrogen electrode, just remember this. This is another type of electrode. It is called standard electrode. Remember, all the activities, all the power of the electrodes are measured with respect to hydrogen electrode. That's why it is called a standard electrode. Now our discussion, we are coming to the final stage of this chapter. These are the very, very important questions. That is electrolysis of molten lead bromide. See, I have drawn one diagram, rough diagram. No need to draw the diagram in the exam. Just I am drawing it for your sake. See, a burner, it is a crucible. Crucible means a plate-like thing. I have taken some molten lead bromide PbBr2. Here the positive and the negative electrodes are there. And what electrode we are used, that is a graphite anode, that is an inert one, and iron or graphite cathode, that is also an inert electrode. And I have just now told you that the difference between an active electrode and an inert electrode. Basically, up to class 10, you will be using the inert electrodes. So externally, see, it is a switch and electrochemical small battery for passage of electricity, supply of electricity, and an ammeter is connected here for measuring the current. So this is the arrangement for the electrolysis. Remember, in exam, these are the questions. So the question you can expect this is write the anode and cathode reaction for electrolysis of lead bromide, or show with the help of an example how electrolysis takes place, or show the electrolysis procedure for the electrolysis of lead bromide. So this is a 3 mark question. So this is the diagram for your sake. I have taken the molten lead bromide. So you should start your discussion like this. That is, first what we have used, first point is electrolyte used. So electrolyte electrolyte used. What electrolyte we have used? We have used molten lead bromide. In exam also write exactly like this. Molten lead bromide, PbBr2. And I am writing here PbBr2, but in exam you should write it molten lead bromide. So first point is over. So the next point you should write the cathode and anode what you have used. So number 2. So cathode used. Cathode we have taken. What cathode we have taken? Iron or graphite cathode. You should mention it. Iron or graphite cathode. Graphite cathode. And what anode we have used? So anode used. Anode we have used another graphite. So these are the things you should write. And remember, for this type of electrolysis we use a very less voltage. Less voltage means the voltage should be less than 10 volts. And temperature, that is a molten lead bromide, it is around 380 degrees Celsius. No need to write those. If possible you can write, but that is not very important. Now the important thing which carries marks, I will be writing it. So you should write it, the reaction taking place. So first see number 4 I should write. Number 4, electrolytic reaction. The reaction which is taking place inside the electrolyte. So electrolytic reaction. Electrolytic reaction. So first you should show here the dissociation of lead bromide, PbBr2. You should write it like this, and don't forget to write molten. Remember, this is very important because otherwise the marks will be deducted. So if we pass electricity through it, it will be dissociated into two ion, that is lead ion and bromide ion, PbBr2. This carries 1 mark. So this is the electrolytic reaction. So here, this is the cation, this is the cation, and this is the anion. So definitely cation will be going to the cathode and anion will be going to the anode. So I will be writing the reaction taking place at cathode. So you should write also like this. Number 5, reaction taking place at cathode. So write it, reaction taking place at cathode. So cathode means I'll be concentrating on lead. So lead goes to the cathode, Pb+2 goes to the cathode, that is plus, it will be going here, it will accept 2 electrons. Remember this one, it will accept 2 electrons from this electrode to form neutral lead. So this is the reaction which takes place at cathode. And we all know when any element accepts electron, what is the reaction going on? Reduction. Remember, so gain of electron means loss of electron is oxidation, gain is reduction. So here reduction takes place. No need to write, if you are unable to remember, no need to write the reduction. Number 6, I will be writing it like this, reaction taking place at the anode. So write it like this, reaction taking place at anode. What the reaction, when you are talking about anode, definitely this thing will be coming in your mind. So look at it very carefully. Br minus, what it will do? It will lose 1 electron to form bromine. Now see here, this is very important. How many electron lead have gained? 2. So here also that balancing thing And in class 11 you will be doing balancing of chemical reaction with the help of electron exchange method. So here the number of electrons gained in cathode should be equals to number of electrons lost in anode. That is called the balancing of ionic method or balancing of ion exchange method. So in order to balance the two electron, there are two bromines. Again I will write Br minus. Again it will lose two electrons. It forms Br. So combining these two, I can write 2Br minus 2 electrons. It becomes how what? 2Br. 2Br we can write, which is familiar to us, that is Br2. So here see here that number of electrons gained and number of electrons lost are same. That means your answer is correct. So this is the process by which you should write. So at anode, at cathode, what will happen? That lead metals will be deposited. Lead will be deposited. What is the color of lead? That is a reddish color. So you can write lead is deposited on the cathode and bromine is a gas. It is liberated at the anode. So lead is deposited. Remember, deposited at the cathode and bromine is liberated at anode. So to sum up, if this is a 3-mark question, remember this portion will not carry any marks. So first this reaction will carry marks 1. This cathode reaction will carry the second marks 2, and this third anode reaction you will be carrying third marks. So this is the 3-mark question. In any type of question like this, so this is, I have done this for your sake so that you can be able to understand it. So 2-3 things I am telling you a 5-mark answer. If this question carries 5 marks, what to do? Draw this diagram. The simple one, electrolyte use is the thing what is given in the question. And remember, cathode and anode, you can use that inert one, that is graphite. It can be applicable for everywhere. The amount of voltage you will be passing through is around 10 volts, and as we are doing it in the molten state, the temperature will be little bit high, so around 350 to 400 degrees Celsius. But the main thing is this electrolytic reaction, the dissociation of compound into its constituent ions, and the reaction taking place at cathode. And whether it is deposited, you have to mention it. Whether it is liberated, you have to mention it. And the reaction in the anode. So prepare this thing very properly. This is very important for your ICSC. Now another example of electrolysis is electrolysis of water, acidified water or dilute H2SO4. So what is that? H2SO4 in the laboratory comes in the form of concentrated acid, and we mix water to it to make it dilute. So ultimately acidified water and dilute sulfuric acid means the same. And this is also very important. Many times it was there in your ICSC exam, and show the reactions taking place at the anode and the cathode and the electrolytic reaction for the acidified H2O or dilute sulfuric acid. The same way you can start here. First of all, number 1, what is the electrolytes we are taking? So electrolyte we are taking H2O and H2SO4. That means acidified water or dilute sulfuric acid. The meaning is acidified water or dilute H2SO4. Next, I am doing it for your knowledge. Number 2, electrode used. What are the electrode? So electrode used. So here also we will be using the inert electrode. You can use graphite here, you can use platinum also. So for electrode we can use platinum inert electrode, or you can write graphite also. So and the electricity, the voltage will be passing that same thing, that below 10 volts, 10 to 12 volts. And remember, we need a very slow electrolytic process in order to the reaction takes place properly. And temperature here is a little bit low because here no molten or fused states are there. So I will be starting with the reaction, electrolytic reaction. So number 3 point I am writing is electrolytic reaction. So electrolytic reaction. So here there are two things. One is sulfuric acid, another is water. So I am dissociating sulfuric acid like this. Sulfuric acid dissociates into 2H plus sulfate ion SO4 minus 2. Along with this, we have got water. Water dissociates like this, H plus OH minus. Now, in your electrolytic solution, you have got the positive ion as H, only one type of positive ion, that is cation. So this is cation. And there are two types of negative ion. One is sulfate ion, another is hydroxide ion. So it is anion. So just now in preferential discharge or selective discharge of anion, what we have learned, if sulfate and OH are there in a same solution, which ion will be discharged first? OH ion, because OH ion is placed below sulfate in that activity series. What you have learned just 1-2 videos earlier, you have seen that in that activity series OH is placed below that sulfur. So as a cation at the cathode, which one will be liberated? Hydrogen. And in anode, what will be liberated? OH, not the sulfate. So this is an application of preferential discharge. If you want, you can write it in your copy as, so this is a note for you. So note, as hydroxide ion is placed below sulfate ion SO4 minus 2. Hence OH minus ions will be liberated at anode. That is another 1 mark question. Remember, why OH ion is liberated at the anode. So this is your answer. So I will be writing number 4, reaction taking place at cathode. So next is reaction at cathode. So this will be your heading. So which one will be liberated at the cathode? Hydrogen will be liberated at the cathode. At cathode, hydrogen will be going there, H plus, and hydrogen ion will gain 1 electron to form a neutral H, or hydrogen atom will gain 1 electron to form H. I am not proceeding further due to some reason. So see here at now number 5, reaction at anode. Reaction at anode. Anode, which one will go? OH. So see here, OH minus will lose 1 electron to form OH. But a radical OH cannot exist independently. So in order to balance it, just remember this. In class 11, we will be learning this more elaborately. Just remember here we have to take 4 OH. in order to balance it. See how I am doing it. Or you can write it like this, 4OH minus, so 4OH, how many electrons it will lose? 4 electrons, so to become 4OH. Now, 4, why 4? You have to wait for one more year. Now up to now, I will be balancing it. So number of electrons gained equals to number of electrons lost. So 4OH will form, see here very carefully, 2H2O plus O2. We have to form O2. How O2 can be formed? See, this is the balanced equation for O2. You have to write here 4 in order to balance. That's why there are 4 electrons. So easily you can write, or 4 hydrogen ion will accept 4 electron to form what? 4 hydrogen. 4 hydrogen will be, I can write it like this, 2H2. So this is the reason. See here, this is 4 electrons gained and here 4 electrons lost. So your answer will be, hydrogen will be liberated at the cathode, oxygen will be liberated at the anode. Now one more interesting fact you can see. 2 volume of hydrogen will be liberated at the cathode, 1 volume of oxygen will be liberated at the anode. And we know for H2O, what is the ratio? 2:1. So you can see in this reaction, you can be able to find the balancing of reaction and the composition of water. That means 2 volume of hydrogen and 1 volume of oxygen will be liberated, and this is very, very important. And go through these 2 portions very clearly. I know few of you have little bit doubt about this 4. So 4, we have drawn 4, we have written 4 for this O2. See, go from the back. If this is O2, this must be 4. If this is 4, this is 4 electrons. And by seeing this, I have written this one. So this is very, very important. At least 3-4 times it was there in ICSE, and this is a 3-mark question. Prepare this very properly. This is also another important electrolysis. This is important because here you can see the electrode plays a very important role in the product. So electrolysis of aqueous copper sulfate means water and copper sulfate are present. So I am doing this in 2 ways. First of all, I am using copper electrode and an inert platinum electrode. So here, electrode we are using at cathode, copper. So here, the electrodes used. See here, electrode used. If I take cathode as copper and anode as an inert electrode, say I am taking platinum, inert platinum, then the thing will go exactly what you all are thinking like this. See, so electrolytic reaction number 1 I will write electrolytic equation. Electrolytic equation it will be like this, that copper sulfate will be dissociated into Cu plus 2 plus SO4 minus 2, and water will be dissociated as H plus plus OH minus. Then the same reasoning, you have got 2 cations and 2 anions. Between cations, you have got copper and hydrogen, and copper is placed below hydrogen in the activity series. That's why at cathode, copper will be liberated. So reaction at the cathode. So reaction at the cathode, you should write it like this. Number 2, reaction at cathode. At cathode, what reaction will, who will go? Copper or hydrogen? Copper. As for the preferential discharge. So copper plus 2 will gain 2 electrons, to form Cu. And what about these two? Just now we have done that between sulfate and OH will go. So I am leaving some gap here, just see how I am doing it. So at anode, what will happen? OH minus will lose 1 electron to form OH. So I will be looking for obtaining oxygen. So what to do? 4. So just we have done this. So I am not elaborating too much about this. Minus 4E becomes 4OH minus, and 4OH minus becomes 2H2O plus O2. So you can easily say that oxygen will be liberated at the anode. So what to do at the cathode? How many electrons? 4. So simply we will be adding another copper here plus 2E equals to Cu. So we will be obtaining 2 copper atom at the cathode. This is a simple way of finding out the electrolytic reaction. Now this is important if we use both anode and cathode as copper. Copper is an active electrode. So active electrode, and remember this is an exceptional case. You should know it very, very properly. Just learn it, memorize it. So here see the difference. Here electrode used. Both electrode, that is cathode will be used as copper. Anode also will be using as copper. So here one thing will be different in both anode and cathode. So electrolytic equation will be same. So we should write it like this. Number 1, electrolytic equation. What is the equation? Copper sulfate dissociates into Cu plus 2 plus SO4 minus 2, and H2O dissociates into H plus OH minus. Up to this it is same, but remember from here little bit difference will be there. So you should write it like this. At cathode, number 2. At cathode, when cathode is copper, then remember the same reaction will take place. Cu plus 2 gains 2 electrons to form copper. And see, the difference lies here. At anode, just remember this portion will be omitted. Copper will lose 2 electrons to form Cu plus 2. So the product obtained at the anode will be nil, because no copper ion cannot be captured or cannot be collected. So here at cathode, what is the product? Copper. Here at the anode, what is the product? Oxygen. Here at the cathode, what is the product? Copper. But at anode, the product is, remember this one, product is nil, because we cannot collect a copper plus 2 ion. Why this copper ion is collected here? Because at anode also we have used an active electrode, that is copper. That is active electrode, copper. Remember this one. This is very, very important, and we will discuss this much more elaborately, but up to class 10, just memorize it or remember it. So it is the application of electrolysis part. There are various applications of electrolysis. This will be a very short video, because we will discuss this in the chapter metallurgy. Remember, metallurgy will start soon. And in metallurgy we will be learning this. There are various applications. I'd like to sum up all these things so that you can answer from it, because these things they will be there in metallurgy very elaborately. Number 1 is electroplating. Number 2 is electro-refining or purification of metals. And number 3 is extraction of metals from its ore. So we will discuss it later very properly. So here I will be briefing you about electroplating. Electroplating. So what is electroplating? So coating of a superior metal like gold, silver, nickel on an inferior metal, that is iron, copper, etc., in order to prevent those metals from corrosions, or in order to make those metals attractive in looks. So we use electroplating. So again I am telling, so coating of superior metals means valuable metals like gold, silver, platinum on an average metal, inferior metals such as iron, copper, to prevent them from corrosion and to look them attractive, we use electroplating. In electroplating, we use a simple technique, that is the same electrolytic cell we will be using. This is the positive terminal and this is the negative terminal. So remember, for outside we will be putting one cell, one switch like this, and that's it. So the articles, this is cathode, remember this is cathode and this is anode. So the articles to be plated will be placed at cathode. Say it might be a gold ornament, it might be an ornament, it might be a spoon, it might be any metallic object. So here at the cathode we should place the articles to be plated, that on which we would like to plate the or coat the other metal. And in anode we should put the metal, that is inferior metal, at the anode. You can use gold, you can use silver, you can use nickel, whatever the thing you like. And here in case of electrolyte, you will be using a suitable electrolyte for coating. So here suitable electrolyte, I will send you a chart regarding this and we will discuss it more in the later classes. So here you should write suitable electrolyte. So just listen to it. For gold we will be using copper orocyanide and silver argentocyanide for silver plating, nickel sulfate for nickel coating, like those. So electroplating is the process by which we can coat or we can plate some superior metal on inferior metal in order to prevent those metal from corrosion or look those metals attractive. Here the articles to be electroplated should be placed at the cathode, and the coating material, that is gold, silver, which is to be plated at anode, and externally a very less electric supply should be there, and we will be using a suitable electrolyte for using electroplating of the devices, and the process should be very slow, remember, and we will discuss it elaborately in the next videos. So the process should be very slow. This is very slow, otherwise the electroplating on that material will not be uniform. So that's it. We will be discussing the second and third point in metallurgy, and we will do electroplating little bit elaborately in the next classes.